Every slow Linux box has the same story to tell. Something somewhere is saturated. In this fourth part, we'll walk through 8 real performance problems and fix them the same way every time. Spot the symptom, reach for the right tool, apply the fix. Memory leaks versus cache. Swap thrashing, file descriptor exhaustion, and CPU throttling. Let's get into it. Before we touch a single command, let's frame the hunt. Everything you'll diagnose lives in one of 4 buckets: CPU, memory, disk I/O, or network, and each one has its own go-to tools. Top and MPStat for CPU, free for memory, IOStat and IOTop for disk, SS and IFTOP for the wire. The trick is the US method. For each resource, check utilization, saturation, and errors. Whichever one's pinned is your bottleneck. Everything else is just a symptom. And speaking of memory, here's the classic false alarm. You run free, see almost nothing in the free column, and start planning an emergency reboot. Don't. The number that actually matters is available. Linux deliberately uses spare RAM as disk cache to keep things fast, and the moment an application asks for memory, that cache gets handed back instantly. No fix needed. This is the kernel doing its job. But sometimes it's the real thing. A process whose resident set just keeps climbing, hour after hour, until the killer steps in and picks a victim. Sort PS by RSS to find your top consumer, then watch that PID over a few minutes. If the number only goes up, you've got a leak. The immediate fix is a restart and cap it with memory max in the system unit so it can't take the whole box down again. Then go find the bug upstream. Now, when RAM is truly overcommitted, you hit the classic swap thrashing pattern. The box feels frozen, CPU sits idle, but the disk light is pinned solid. Run vmstat 1 and watch the SI and SO columns. If they're constantly non-zero, the kernel is shuffling pages between RAM and disk just to keep going. The fix is the same shape as before. Free memory by killing or restarting the hog. Drop vm.swappiness so the kernel is less eager to page out, and longer term, just add more RAM. Memory isn't the only thing you can run out of. File descriptors are just as easy to exhaust. When an app starts rejecting connections with emfile or too many open files, count what it's actually holding. With lsoff ppid pipe to wcl, then check the ceiling in proc PID limits and you limit. If you're genuinely near the cap, raise it, limit no file in the system unit, or you limit N6553 in the shell. But be honest with yourself. If the number keeps climbing, you don't have a limit problem, you have a leak. Find the code path that forgot to call close. Now here's a classic head scratcher. Uptime shows a load average of 30, but top says the CPU is barely breaking a sweat. Don't go hunting for runaway processes. Load average on Linux also counts tasks stuck in uninterruptible sleep. That D-state you'll see in PS. 9 times out of 10, that's a slow disk or a stale NFS mount blocking your processes. Check %WA in a top, grep for D-state processes, then run IOStat X1 to find the real culprit. Fix the I/O, the load drops on its own. Speaking of physical bottlenecks, sometimes the CPU itself is throwing in the towel. If your compile jobs or number crunching workloads have quietly gotten slower over the months, the silicon may be overheating and dialing back its own clock to protect itself. Run sensors to check temperatures, then watch the mHz column in proc cp info under load. If you're sitting well below the rated max, that's thermal throttling. The fix is physical first. Blow the dust out, reseat the thermal paste. Then make sure the governor isn't stuck on power save. Flip it to performance with CPU power and you'll get your headroom back. From silicon to software, now the system can't even spawn a new process. And you're staring at can't fork errors. Start by counting. PSE pipe to WC. L tells you the scale, and grouping by parent PID with PS. EOPPID sorted and uniqued shows you exactly who's doing the spawning. Once you've spotted the culprit, kill P on the parent collapses the whole tree in one shot. Then make it a one-time event by capping mproc per user in xsecuritylimits.conf, because if it happened once, it'll happen again. Stay up the stack, and we hit the network layer. Your server's crawling, and SS reveals a sea of time-wait sockets, the lingering ghosts of short-lived TCP connections. Confirm it with SSS for the summary, or pipe SS, TAN state time-wait, into WCL for an exact count. The real fix isn't just flipping TCP TWU rows in SysAdmin. That's a band-aid. The actual cure is upstream, connection pooling, keep alive, and apps that stop slamming the kernel with a fresh socket for every request. Now let's pivot to memory and clear up the single biggest source of false alarms on a Linux box. Junior admins see free memory near zero and panic, but that's almost always cache, not a leak. Cache is Linux doing its job, filling idle RAM with disk pages to keep things fast and handing it back the instant a process asks. A real leak is different. A process's RSS climbs and climbs, never released until the killer steps in and picks a victim. One is healthy, the other is a bug. Before we dig into more scenarios, let's lay out the toolkit you'll actually reach for. Top or HTOP for live CPU and per process view. Free-H for memory, where the column you trust is available, not free, and vmstat1 to watch swap activity and the run queue tick by. Then iostat-x1 for disk I/O and IO8, ss-s for a quick socket summary, and LSOFF and sensors when you need open file descriptors or hardware temperatures. 6 commands, and you can diagnose almost anything. With that toolkit in hand, here's the flow I run through whenever someone says the server's slow. Start at the top. Is CPU maxed out? User plus system time pegged? If not, check IO8. High %WA means you're waiting on disk, so IOStat next. Still nothing? Look at memory and watch for SYSO in vmstat. That's swap thrashing. If load average is high, but CPU is idle, you've got processes stuck in D state on I/O. And finally, check the network with SS or IFTOP. Buff 5 questions under a minute, and you've narrowed it to a resource. Speaking of load average, this is the number people misread more than any other. Those 3 values are 1, 5, and 15-minute averages of processes, either running on CPU or stuck waiting in uninterruptible I/O. Which is why a high load with idle CPU usually means disk. Always compare against your core count. Load of 4 on a quad core is fully utilized. On a single core, it's drowning. And read the trend. If the 1 minute is higher than the 15, things are getting worse. If it's lower, you're recovering. Which brings us to the anti-patterns, the mistakes that turn a small problem into an outage. Don't panic at low free. Linux caches on purpose, so read available instead. Don't read load without knowing your core count. Don't only tune the kernel when the real fix is an app opening 10,000 connections. And above all, don't kill symptoms. Restarting a leaking process buys you an afternoon, but the leak comes back until you actually patch it. So let's flip it around. How do you keep a box fast in the first place? Cap the runaways at the system layer with memory max, CPU quota, and limit no file. So a misbehaving service can't take the whole host down. Keep a little swap for healthy overflow, but never let it become a crutch. Graph CPU, RAM, and I/O over time so leaks show up as a trend, not a 3 a.m. page. And pool your database and HTTP connections. Reuse beats reopening every single time. And with that, here's the whole session on one screen. RAM that looks full is usually just cached. Read available, not free. Real leaks show up as RSS climbing forever. Swap pane shows up in vmstats SI and SO columns, and exhausted file descriptors get fixed by raising limit no file. High load with idle CPU means you're waiting on I/O. Thermal throttling means you're waiting on physics. Fork bombs die to kill, P, and time wait. Floods melt away once you reuse connections instead of reopening them. Same loop every time. Spot the symptom, pick the tool, apply the fix. If you remember nothing else, remember these 4. Find the saturated resource, CPU, memory, disk, or network. One of them is always the bottleneck. Cache isn't a leak, so trust available over free. Load average only means something once you divide it by your core count. And restarting buys you time, but it doesn't fix anything. Patch the leak, pool the connections, address the cause. Here's a quick glossary to keep handy. RSS is the real RAM a process is holding, not what it reserved. Swappiness tunes how aggressively the kernel pushes pages to disk. IOWait is your CPU sitting idle, waiting on disk. File descriptors are the handles you'll run out of when a service forgets to close sockets. Load average is processes running plus waiting, averaged over 1, 5, and 15 minutes. And time wait is just a closed socket cooling off, normal until there are tens of thousands of them. So that's the whole game. Every slow system comes back to one saturated resource, CPU, memory, disk, or network. And your job is always the same loop. Measure it, read the numbers honestly, and fix the cause instead of the symptom. If this part clicked, the full series, Classics, Cron, and SSH, Boot and Systemed, and this performance deep dive is waiting on Dargslan.com. Subscribe, share it with the junior on your team, and I'll see you in the next troubleshooting session.